Hello everyone. Today let's solve the problem number 84, largest rectangle in histogram. So you can just go through the question. You can just go through the examples as well to understand the question clearly, right? So I'll just summarize the question so that it will be easier to understand. So first thing is what the question states here. We are given an histogram represented by array of integers. You can clearly see here array of integer heights. So we are given an histogram represented as an array of integer heights where each integer denotes this one, the height of a bar with width 1. You can clearly see here where this one you can clearly see here, right? Where each integer denotes the height of a bar with width 1, 2, 1, 5, 6. You can clearly see here the width of each bar is 1 they have given here. So what is our main goal? Our main goal is to find the area of the largest rectangle that can be formed using one or more consecutive bars. So we have to find the largest rectangle that can be formed using one or more consecutive bars. So you can clearly see here one or more consecutive bars. So here the larger one is 10, right? The largest rectangle that can be formed using one or more consecutive bars. Here you can clearly see they have made use of the two consecutive bars of same height. This is so the largest rectangle that can be formed here according to this example here is 10. So the output will be 10. That's what they have given here, right? So they have clearly given in the explanation as well. It's a histogram where width of each bar is 1. The largest rectangle is shown in the this one red area which has an area 10 units. This is fine. Same goes with the example 2 as well. You can just go through example 2. So first what we'll do, let's discuss the approach and then let's discuss the edge cases one by one and then write the code and discuss the complexity of the code that we have written. So let's go with the approach as usual. So let's discuss the approach step by step. Let me give you approach. So first thing is we have to keep in mind we are going with the monotonic stack here. So we are just going with monotonic stack approach here. So first thing, let's go step by step as I've said. First thing is we are making use of stack to keep track of the indices of the bars. So they have mentioned the bars, right? If you would have observed while I was explaining the example. So we are making use of the stack to keep track of the indices of the bars in the increasing order of their heights. This is very important. So we are making use of the stack to keep track indices in increasing order of heights, right? So this is first thing, right? So let's move on with the second step here. So second step, what we'll do, we will traverse the array. Obviously we'll traverse the array whenever we encounter a bar that is shorter. So I'll just give here, we'll traverse the array. So here within this one, whenever we encounter a bar that is shorter than the bar at the stack stop. So whenever we encounter a bar that is here, let me give here shorter than bar at stack top or stacks top here. What we will do here, whenever we encounter a bar that's shorter than bar at the stack top, we calculate the area of the rectangle with the bar at the top of the stack as the smallest bar. So we are calculating the area of the rectangle with the bar at the top of the stack as we are calculating bar at top of the stack as the smallest bar. We are considering this one as the smallest bar. So this is very important, right? You'll understand this one very clearly when we write the code. So this will be the second step. Let's move on with the third step. Nothing but we will be continuing this process until we have processed all the heights. We have to process all the heights, right? So we'll be we are traversing the array. So we'll continue this process until we have processed all the heights, including a dummy height 0, right? That one as well at the end, including the dummy height 0 at the end. Why? Because to flesh out the remaining indices, to flesh out remaining indices, right? So this is the approach that we'll be going with. So we'll be going with the monotonic stack. The first step is we are making use of the, so I'll just come here. We are making use of the stack to track the indices in increasing order of their heights. And the second one is we are traversing the as we traverse the array, or we are traversing the array, right? So as we traverse the array, whenever we encounter a bar that is shorter than the bar at the stack stop, we calculate the area of the rectangle with the bar at the top of the stack as the smallest bar. That's what I have given here. This is simple to understand. Finally, we'll continue this process until we have processed all the heights, including a dummy height 0. Why dummy height 0 we have considered here? Because at the end, to flesh out the remaining indices, because we have to flesh out all the remaining indices, right? That is the reason we'll be considering this one, dummy height 0 as well. So this is fine. Let's discuss the edge cases one by one. And then, so let's go with the let's discuss all the edge cases here. Let me give edge cases here. The first one, let me consider single bar of, while I say single bar, I'll just consider here height equals 1. While I consider height equals 1, let me consider a quick diagram here. So this will be 0. Here width they have given. So width will be this one, height let me consider 1, 2, 3. So height they have given 1, and every width will be of 1 they have mentioned in the this one question. So this they have given 1 here, height of 1. So the output will be 1 itself. Why the output will be 1 itself here? Because we are having only this one to consider, right? So that is the reason the output will be 1 here. We are having only single bar, right? So again I'm telling why the output is 1 here. Let's consider output. So we are considering output as 1. Why? Here the largest rectangle is the height is the single bar itself. Here you can clearly see this bar we have considered, right? This one. The largest rectangle is the single bar itself. So the output will be 1 here. This is for the single bar condition, single bar. So let's move on with the second edge case. Nothing but all bars of same height. So while I say all bars of same height, I'll consider the input height. Let me consider some random height. So I'll just give here 2, 2, 2. This is just for the example set, right? So this is fine. Here it will be same thing. So we have considered every bar has same this one, right? So this should go up to this one. The width will be, the width for each bar is 1 they have given in the question. This is of height 2, 2, 2 and 2. So the output will be 8 here. So 2, it is of same height. So we are considering the entire this one. The largest rectangle here formed is using the consecutive bars starting from the first here 0 to 4, this one. This will be 2 plus 2 plus 2 plus 2, nothing but 8. So the output will be 8 here. This is for the condition all bars of same height. Sorry, yeah, all bars of same height. This is fine. This is the second edge case. So let's move on with the third edge case here. So this is for decreasing heights. So let's consider the heights. While I say height, decreasing heights, let's consider 5, 4, 3, 2 and 1 here, right? So This will be, we can just give here, we have 5, right? But so this will be, let me consider this one very quickly. This one, sorry, 5. The first one will be here 5. The second one is 4, and the third one is decreasing order we have, right? 3 and 2, and finally this is 1. So the largest rectangle here, the largest rectangle is formed using the consecutive bars starting from the first. This one you can clearly see the most, this one, right? This one. This one forms the largest rectangle, right? So this will be actually here this one is 5 and this one is 4. So a height of 5 and 4. So it will be 5 plus 4. So the output will be 9 here. So the largest rectangle formed here is using the consecutive bars that is starting from the first. So the output will be 9 here. This is for the condition decreasing heights. Let's move on with the next edge case. So let's consider the edge case empty heights array. So I'll just give here empty heights array. So while I say empty heights array, I'll just consider here height of the input heights. I'll just empty array we are considering, right? So here we don't have anything. We don't have any bars at all. So there is no rectangle. So output will be 0. I don't have to draw in a diagram here. So no bars at all means there is no rectangle. So output will be 0. The final one, the final edge case, we are going with the bars with height 0. So let me consider here height input. I think but 0, 1, 0. So we are going with bars with height 0, right? So let me quickly give here 0, 1, 2, 3, and this one will be 1 and 2. So first one is 0 itself. This will be 0 itself. The second one will be this one 0 we are not considering. The second one will be 1, height of 1. The third one will be, again it will be 0. So this will be actually this one we will consider, right? The largest rectangle that is formed is this one, and here we have 1. So the output will be 1 here. So this is for the condition bars with height 0, right? So these 5 edge cases that we need to keep in mind. First thing is for the single bar. Second thing is for the bars of same height. And the third one is for decreasing heights. And the fourth one is for this one, empty heights array. And the final one is for the bars with height 0. I hope every edge case is clear. So next, let's start writing the code. I'll explain the code while I write the code itself. And then finally, let's discuss the complexities of the code that we have written. Let's quickly write the code here. First thing is, as we had discussed in the approach, we'll be going with the monotonic stack. So let's go with the monotonic stack to store the indices. So let me quickly initialize the stack to empty array. So here, next, let's go with the variable to track the maximum rectangle area as well. So we have to calculate the max rectangle area as well. I mean, that itself, right? So I'll just be initializing the max area initially to 0. Third thing, the second thing is the main step. Let's traverse through the each bar in the heights array. So we have to include the dummy bar at the end as well. So while explaining that approach that I have already said this one, we have to, this is very important. I mean, we have to, while traversing through the each bar in the heights array, we have to include the dummy bar at the end as well. So I'll quickly give you, or let I equals 0, I less than or equal to, right? So we are including the last, this one, including a dummy bar at the end as well. So that is the reason I'm giving equal here, less than or equal to the length of the height. And let me increment this one. So while stack is not empty and the current bar is shorter than the bar at the top of the stack. So further we have to pop the top bar and get its height, right? So how can I write this one? So we have already discussed this one. Let me go with the while loop. So while a stack shouldn't be empty, right? So let me consider here stack dot length, and also the current bar should be shorter than the bar at the top of the stack. So how can I write that? Another condition I'll just write here, I equals length of the height or heights stack. I'll just consider it here -1. -1 nothing but we are considering this one, the current bar, while current bar is shorter than the bar at the top of the stack, right? This one we can just write here greater than heights of iterated value of the heights. So then what did we discuss? We have to pop the top bar and we have to get its height. So I'll just give here height. I have already considered, so no, I haven't, right? So h I'll consider here a variable name heights of stack. We are popping right here. So we have to pop the top bar and get its height. So I'll be making use of the pop function here. So then after popping the top bar and after getting the height, we have to calculate the width of the rectangle. How can we calculate the width of the rectangle? I'll just take w here for the variable name. If the stack length is not empty, the length of the stack, I mean if the stack is not empty, then let's go with the this one, I minus stack -1 then or else I. So we are just calculating the width of the rectangle. So final thing is we have to update the max area if a larger rectangle is found. Whenever we find the larger rectangle, we have to update the max area, right? For that purpose, I'll just make use of max area. Yeah, I'll just have the math, this one, right? Math.max to find the maximum. So maximum we get by calculating height into width. Area is calculated by height into width, right? So that's what h into w I'll give here. This is fine. Finally, we have to push the current index onto the stack. So stack dot push I'll make use of. We are just pushing the current index where we have found the max area. Let's return the maximum rectangle area at the end. So I'll just give here maximum area. That's what we need to calculate, maximum area, right? Let me format this one and let me run the code. So here height is not defined. Heights, we have heights here. Sorry, let me give here. Yes, let me run this one again. Again we are getting line number 6. Again this has to be heights. So max area, math is not defined. Math it has to be. So yeah, h let me give here. So many typos. So yeah, now you can clearly see all the test cases are getting passed here, right? So let me hit the submit button now. So you can clearly see all the test cases are getting passed here, right? So the code works absolutely correct. So let's quickly discuss the time complexity and the space complexity. So the approach that we went with here is monotonic stack. We know that. And the overall time complexity would be here big O of n. Why it will be big O of n here? Because each bar is pushed and popped from the stack exactly once. So you can clearly see here. We can see the stack operation right here, especially here from here. So push and pop we are making use of. Each bar is pushed and popped from the stack exactly once, resulting in the linear traversal. So the overall time complexity would be here big O of n. And what will be the space complexity here? So the overall space complexity would be big O of n as well. Why? Because we know that one thing, the stack can store up to n indices in the worst case. We know this one, right? So the overall space complexity would be here big O of n. So yeah, I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.